Hello everyone. Today I'll present our work on enhancing retrieval-augmented generation for biomedical question answering. Our goal was to improve multi-hop reasoning in LLMs using Wikipedia as a knowledge source. Let's dive in. LLMs often hallucinate, especially in high-stakes domains like biomedicine. RAG helps by grounding answers in external knowledge, but standard RAG struggles with multi-hop question, like connecting facts across documents. The limitations are listed on this slide. As you can see, there's the brittleness of semantic retrieval, the context poisoning, the artifacts which come from inappropriate use of chunking strategies which we must perform on the documents in our knowledge base, and there's also the high sensitivity to prompt structures. Our work tackles two key issues: noisy retrieval and degraded outputs when synthesizing multi-source information. Our solution combines three innovations. First, we perform hybrid search, which merges keyword and semantic retrieval for better recall. Second, we use reciprocal rank fusion to re-rank results and possibly reduce noise. And lastly, and the most critical detail, is that we decompose complex questions into simpler sub-questions. The decomposition procedure is done purely with large language models such as Llama 3 Med42, which comes with 8 billion parameters. And it's also a domain-specific fine-tuning of Llama 3, which is mostly on biomedicine. And we do it purely locally. We do it on our machine with Ollama inference. The retrieval is done with ChromaDB and BM25S, both of which are integrations of LangChain and is written in Python 3.10. And the reciprocal rank fusion is done with the FlashRank re-rank tool, which also comes with Python 3.10. We built our system using around 225,000 Wikipedia health articles, and we retrieved those using the PetScan tool. And the retrieval was done based on subcategories and categories in medicine and health. We split those documents using the recursive chunking strategies, and each fragment is of 512 length in characters, and they overlap in 32 characters. Our results show a 0.53 exact match score, which is a solid baseline in our opinion, though complex queries still need improvement. Median scores also reached 0.63, and for each run, we only changed the prompt structure. We didn't touch the retrieval weights or retrieval parameters. Challenges remain for niche queries like rare disease interactions. Future work includes few-shot prompting and tuning retrieval weights. Importantly, our framework is adaptable. Other knowledge bases or large language models could be integrated. In summary, we think that hybrid search and prompt decomposition techniques boost RAG for biomedicine, but careful implementation and ablation studies are needed to further research. Our code is available on GitHub. You can try it, but you will need to install the Jupyter notebook to use the full functionality we made. I would like to thank you for your time, and feel free to email me any questions you have. Thank you.